Okay, thank you very much for having me speak here. Thank you for the organizers. And let me get started with the first slide. Okay, and this is the conference. Actually, most of you know that this was the conference in February, which unfortunately for reasons we could not avoid had to be cancelled. But most of you don't know is that the next slide is that actually I then came and gave a talk to MIWA for the state of the microalgae in the kingdom, both macro and microalgae, and in particular on the focus of animal feeds. And that is basically the talk I'm going to give here today also in the context of the talk that the state of the microalgae industry of the world. Okay, so starting with that, I'm excluding China and the EU since you already heard that before. The organizers allowed me to spend 5 minutes to talk about MicroBio Engineering, the company that I founded with partner Trig Landquist, and we have about 25 employees right now working on many projects, but covering the whole area of microalgae from process design to microalgae strain development, and of course techno-economic analysis and so on. We work with many different companies. This is just a few examples of the companies we work with and we have worked with in the past and in the future, and also all the Department of Energy International Laboratories. Most of our funding, about 75–80%, is from the Department of Energy, and we also work with the California Energy Commission and also a member of the Algae Biomass Organization and the EABA. We have a fairly large number of ponds that we use in our research at the local wastewater treatment plant, and we do work on wastewater for nutrient removal, but also on strain development and many different type of projects there. I just want to mention a couple of projects that we have done. One of them that is a thing of particular interest in this context was the Orlando Utilities Commission in Florida, where we worked for several years on developing a process for filamentous algae growth on the power plants, on CO2 effluents from the coal-fired power plant. And you can see the young lady there holding up a lot of algae that she just could grab out of the ponds. It's very easy to harvest to remove the filamentous algae. Very nice process. And in the process, while we were doing this, also in the production of the algae, we looked at the economics of that. And basically, you can do the economics, but you have to do this if you want to compete with animal feed production. For animal feed production, you have to do this at a fairly large scale. And I will talk about that a little bit later also. But that's the general concept. We have, as part of that project, also used the algae for animal feed, specifically for chicken feed production, and that was also quite successful. But of course, there have been many studies over the years on animal feed production from algae, so that's not a novelty. What we looked at also is the value of these microalgae and for animal feeds. And of course, animal feeds, as we know, is fairly cheap, a few $100 per ton. If you buy soybeans, maybe these days about $500–600 per ton. But if you look at the content of the algae in terms of the xanthophylls, the carotenoids, and also the omega-3 fatty acids, the algae that we were growing at were fairly high in EPA. So that you have a value there. The oil of the algae is not a very high value. But if you add it all up together, you can have a value of $1,000 to $1,200 per ton, which is interesting from a production point of view. One of the major subjects that we have been investigating is how to obtain CO2. Like, of course, you all know there's a lot of CO2 from power plants and so on, but where you can grow the algae, you don't always have CO2. In China, for example, I have studied several of the production facilities there, and nobody in China uses CO2. It all comes from the air or from bicarbonate that's added to the cultures. So we have been looking at, of course, growing algae on air is fairly straightforward, but it's not that as productive. So we looked at the a project called AirCap, abiotic in-gassing experiments with increasing the pH and bringing in CO2 from the air. And we did this project both in the laboratory and at small scale, but also the larger scale at the Qualitas Health Facility in Imperial, Texas. You can see these unlined ponds, which are very low cost. And however, I would say that that did not work out very well. The pH required is too high. So we are working now on a project with the Sinotech Corporation in Hawaii, and we're looking at two processes. One of them is just capturing CO2 from the air with global thermostat, and the other one is to, within Pacific Northwest National Laboratory, to develop strains that have a high carbonic anhydrase to bring CO2 in from air. This is still ongoing project, so we don't have any strong results yet, but it looks very promising. So, final point I want to make is Microbial Engineering is also working with a company, Tom Algae in Belgium, and actually we are part owners, and we're working jointly with them. And this is a completely commercial process. It has no government research involved, and it's a production of a freeze-dried product sold in the shrimp industry as for the hatchery and nursery operations, and also for bivalve production. Okay, so I think that that almost covers the subject. Gabriel also mentioned wastewater treatment. It's a subject dear to my heart. I've been working for many years in that, and we are working on several plants that use algae for wastewater treatment. But at that point, you're dealing not with, of course, animal feeds, but you're dealing with biogas or bio oil, and that's actually one of the projects that we have. Our major project now is in conversion of both the bacterial wastewater sludges from primary wastewater treatment and also from algae waste treatment plants for hydrothermal liquefaction for the production of sustainable aviation fuels and other oils in a commercial process. Okay, let me talk about the state of the microalgae industry in the world. And there is, of course, the question, what do we mean by that? And I will just focus only on autotrophic production using sunlight and CO2. And we heard various discussions, and people argue about what is the actual scale of that industry in the world, and somewhere between 10 and 100,000 tons per year. We think it's about probably close to 50,000 tons, but again, that's more or less a consensus estimate. And as you heard, spirulina, chlorella are the two major algae, and then we have Dunaliella, Haematococcus, and Nanochloropsis, which are relatively minor producers. But basically, almost all of it is consumed for human foods as supplements or for extraction of beta-carotene, astaxanthin, omega-3 fatty acids, and phycocyanin. What about all these other products that people talk about, from biofuels and bioplastics and aquafeeds and biostimulants and cosmetics, etc.? And what I will mention there is that these are all either non-existent, like biofuels, and from a commercial perspective, or they are very small scale or very minor products. So we're not talking about very much in that regards. And I should say that heterotrophic production I do not consider as applicable under the Saudi conditions, because that just requires import of some particular sugar. So you might as well just do that in Brazil, where it's a better place to do that. And I will only talk about the larger scale production, at least 100 tons or more, in this review. And so basically that restricts us to three main parts in the world: India, Australia, and the United States. And let me just mention India very briefly. I worked in India for many years with a company called Pari Nutraceuticals, which is part of the Ambadi group in India, and a very nice plant of production of several hundred tons of spirulina and also of Haematococcus, very standard production of paddle wheel raceway ponds, which is what most of the systems are for large-scale production. India has many other companies. I will not go into the details. It's all spirulina pretty much. And there's a recent publication on that, not publication, but summary from spirulinasource.com that you can get. And actually it also covers China and India in Australia, etc., and North America, a very good overview of these technologies. In Australia, there's basically only two algae production systems for commercial size. One of them is from a company, BASF, formerly Cognizant from beta-carotene. In Western Australia, large-scale ponds for beta-carotene production by Dunaliella salina, and you can see the red ponds, and that is a natural, more or less natural bloom, supported with some fertilizers that are added. All the white that you see around there is salt. These are salt evaporation ponds. The Dunaliella grows at 150, 200 grams per liter of salinity, very high salinity, very low productivity, but very high value product. And there's a similar type of production facility in Whyalla in South Australia, and those two production systems are pretty much most of the beta-carotene produced in the world from natural beta-carotene. Okay, so let's get to the final one in the United States. In the United States, I can really summarize it with three different companies. One of them is Earthrise Nutritionals, which has been operating since about 1980 in Southern California. And basically, they produce both spirulina for human food consumption, nutritional products, and since 2015 or so, they have been extracting phycocyanin from the spirulina. Again, this is you saw a picture of this before, the larger ponds actually that are over there are several 2 or 3 acres in 2 or 3 hectares in size, but they're not really used for production. They're used for management of the effluent. The liner blue plant that you see there in the bottom, and you see the plant expansion area that has been sitting there without plant expansion for the last 15 years or so, because actually all the liner blue is actually produced with spirulina imported from China. And I just want to show this picture to show you what is the current state of the art, what is the current commercial production of microalgae compared to alfalfa production in the Southern California Salton Sea. If we really want to go into commercial microalgae production on a large technological level for animal feeds, we have to go from the small scale that you see there, which is about 20 hectares of algae ponds, maybe 40 hectares in terms of the total land area, and become something like the alfalfa fields. This is the other plant. It's Qualitas Health. I already mentioned it before. We have worked with them recently on CO2 utilization, and they produce nanochloropsis. That is, however, their production system did not work out as anticipated, which is not unusual in the microalgae field, and so they went and made a collaboration with a company called NBO3, which is actually an animal feed production company that actually bought the abandoned sapphire ponds in Columbus, New Mexico. And those are the largest ponds in the United States. It's 100 acres, it's 40 hectares. And they produce a collaboration between Qualitas Health and NBO3. They produce nanochloropsis, which is then extracted for omega-3 and sold in the human nutritional market. It is not publicized how much they produced, but we can expect it's going to be, probably a few hundred tons. I should mention that Sapphire actually built this plant at well over several $100 million. Actually, they spent over $500 million on the whole project, which was a complete failure because of the fact they were trying to make biofuels without having the technology. It didn't work too well, and one of the reasons was because their construction costs were very high, $650,000 per hectare, without any of the infrastructure or harvesting or processing, just for the ponds themselves. And when they said, okay, that's too expensive, while we can optimize it and reduce the cost a bit, it's still too expensive. Leidos, which was a contractor for DOE, came in and said, well, if you take out the liner and just put clay line ponds like what you saw with Qualitas Health, we could reduce it to maybe $200,000 per hectare. And what we said is, if you want to really go into animal feed production or into low cost, production of anything, you have to go to much larger ponds, 4 hectare ponds. And that's really the message that I want to give you here. So the final company that I want to mention is Sinotec. And Sinotec has been in the business also for the last 40 years in production of spirulina and then more recently Haematococcus pluvialis, a very nice facility. We are working with them, and actually there's going to be a meeting in Hawaii in a couple of weeks, or actually maybe 2 weeks from now. And however, Sinotec is a very interesting situation because it's a successful company, but if you look at what happened to them in the stock market, you can see about 30 years ago they were very high valued, and since then they have had a very hard time keeping up the price. Why is that? Because basically production is expensive in Hawaii, and competition from China and from other places has been tough, so that they have been really going down in the market. And that's one of the take-home lessons here. If you want to be successful in business, you have to be not just producing a nice product. So what is the relevance of all of this for Saudi Arabia? I think that really the only reason for Saudi Arabia to produce microalgae is because there is a real need for production, an existential need for production of animal feeds in the kingdom. You only have seawater as a water resource, and the only thing you can grow on seawater is algae, microalgae and microalgae, but you have to be able to reduce the cost to as low as possible. And that requires some scale up far above what we have been achieved. Instead of 1 acre or half hectare or 1 hectare ponds, 4 hectare ponds and hundreds of hectares in production scale. And forget about being distracted by high value co-products or biofuels or heterotrophic production, as I mentioned before, do that in Brazil. And the current commercial experience that we have in China and Europe and the United States tells you where the animal feed production in Saudi Arabia could go. So there are many, many issues that you will have to address in this process, and I won't go all of them, but of course productivity is always a big one, protection of the crops is another one, but I think the most important one is going to be the plan, how to develop, how to implement, how many centers do you want to have, and we're going to hear on, I think tomorrow or day after tomorrow, from KAUST, from Claudio Freitas-Grunewald, about the very nice project that they're doing there. And I just want to leave you with the concept that, yes, for the last 15 years, we have been working with Aqua, with MIWA, actually I even worked with Aramco, to bring this concept to Saudi Arabia. This is the pilot plant in Aqua, and that could be sited there. And we also designed an 800 hectare module that could be, or a system that could be designed and could be located at the site between an Aqua and the desalination plant south of Jeddah, which would be a very good site for initiating a large-scale production facility. So that's my recommendation. I think that the only last concept I want to leave you with, scale-up is necessary, scale-up is hard, and a lot of people think that they can just scale up, going from laboratory or from small scale or from 1 hectare to multiple hectares, and it's still going to be a major job. So this is the team that I work with, and we have, of course, many other team members on this, but I want to thank in particular Yusuf Al-Hafed from MIWA and Claudio Freitas-Grunewald from KAUST and Haida Al-Hashoud from NLFDP, who made it possible for me to be here, and of course all the other organizers of this conference. Thank you.
Thank you indeed. I'd like to invite all the panelists on stage, please. I'd like to remind you that the topic of this session is State of the Algae Industry. This session will be moderated by